Hello, in this video we will see how to encrypt an image. Encryption consists of permutation and substitution. Here, we will see the code for encryption with the substitution method alone. In the next video, we will see how to shuffle the pixels with the permutation method. I am using the keygen program to generate the chaotic nonlinear keys. Please visit the previous video on how to generate chaotic keys with the logistic map. You can find the link of this video in the description box below. Coming to the program, I am reading the image and displaying it. Next, I generate the chaotic keys. For this, I am calling the keygen function. I pass the values 0.01 as the initial parameter, 3.95 as a control parameter to the logistic map. I need to generate the number of keys which is equal to the size of the image. So I pass height into width for substituting all the pixels in the image. Next is the most important and interesting part of the program, which is substitution. Here, this is done with a simple XOR function. Every pixel value is XORed with the chaotic key. By performing this step, all the values are changed. I also write the decryption function in the same program. Here again you can notice that every encrypted pixel value is XORed with the key to get the decrypted pixel values. Let's see the output. So this is the original image which is to be encrypted. Here you can see the random set of chaotic keys. You can notice that it is in the range 0 to 255. Remember, we have used mod 256 to generate the values in this range. This is because the pixel values in the image fall in the range 0 to 255. This is the encrypted blurred image. And here you can notice that after decryption, the original image has been obtained. Now let's see if we get the original image if we change the key values. So here I generate a new set of keys by changing the value slightly. Let's see the output. This is the original image to be encrypted. This is the encrypted image. And this is the decrypted image. You can notice that the original cameraman image is not obtained. This is a simple example of symmetric encryption where the same key is used for both encryption and decryption process. Thank you for watching.